If x is real, find the possible sets of values for the function y equals x squared x plus 1. Alright. What do we never want the denominator to be? We never want the denominator to be what? Anybody? The x value can never be minus 1. Why? It sets the denominator to 0 and then that's undefined. Are we cool with that? Alright, so x can't be minus 1. Find a set of possible values for this, alright? So, okay. Let's you can do a bit of a table function here if you want, alright? And here's what we'll do with the table function. We'll go menu. The table function subs in random numbers of my choice. I'm going to go from minus 10 up to plus 10, and I'm going to have a look at what happens to this function when you sub in different values of x, just to get a feel for it. Minus 10, and 10, step of 1. Alright, so everybody see the value minus 11.1 for minus 10. Then go down to minus 5. It's minus 6.25. Can everybody see that it's getting more positive now, isn't it? It was negative, but now it's getting a lot more positive. Okay, then we keep going down. This is where there's an error. Why is there an error? Yeah. Now it's going to go from minus 4 all the way close to 0, isn't it? In fact, it equals 0 when x itself equals 0. So it goes from negative values all the way to 0, and now it's gone from 0 all the way up to like whatever value we want. So for me, it's going to go all the way from minus infinity all the way up to plus infinity, isn't it? All the y values will be represented. Okay? Now the only value that's not represented is what? When x equals minus 1. Alright? So if we were to draw this graph, I'm going to show you how to draw this graph, alright? So I'll show you what we're talking about now. So the story, the x squared divided by the x plus 1 on the bottom. Sorry, no. Backspace. Divided by x plus 1. Now, you see, it's a very weird diagram, okay? So, what you know is about the diagram. What value can it not cross? It won't cross y equals minus 1. Oh, sorry, x equals 1. Do you see the way it just gets closer and closer, but it never actually crosses that? See the way it never crosses that line in a horizontal direction? And likewise, at the very top, see the way it never crosses x equals 1. Alright? Now, what y values do you see aren't represented here? There is a couple of y values that aren't represented. Minus 1, minus 2, and minus 3. They actually aren't represented. That's interesting. Right? So, when you go back to your calculator, see the way it jumps from minus 4 up to 0? Sorry, minus 4 up to undefined. And then it starts at 0. That's basically this little part here. Sorry, I'll chop this off for you. Okay. So, when you draw this graph, you can see that that's 0, 0. Okay? And this is x equals minus 1.1 is actually an extremely negative value. So check this out. Go back into your calculator and have a closer look at minus 2, minus 1, 0 and 1. So here's what we're going to do. This time I'm going to start at minus 2. I'm going to end at minus 1. I'm going to end at 0. I'm going to do a step of 0.1. And what's this going to show me? Look at this. Minus 4, yeah? It's actually getting more negative now, isn't it? Actually, sorry, one sec. Minus 3. Call it 0.2. Just stick with me. See the way it's minus 4.5 for minus 3? And see the way it's getting less negative. And then what happens all of a sudden? It gets to minus 4, and what happens then? It turns and goes back down again. And we can see that here, can't we? It's getting more positive, reaches minus 4, and then turns around and says, nah, I'm going to go more negative. And that's reflected in those numbers, isn't it? Do you see them? So you have to be able to picture this in your head. That's where it's getting more negative. And then it keeps getting more and more negative. Do you see that? Now if I take a look at 1.2 to 1, look at what happens here. Minus, just call it minus 1.1. Call the n minus 1. Call the step 0.01. Now look at this. 1.1 is 12.1. Minus 1.09, 1.07. What's happening to those numbers? They're getting very negative, aren't they? Minus 1.01 is minus 102.01. That's when it's going all the way down here. Okay? So the bottom line is, it never gets beyond the y values, or the outcomes. They never get beyond minus 4. Is that okay with you guys? Now, on the opposite side of the spectrum, what we have here is when x equals 0. So we go from start at minus 1, end at 1, do a step at 0.1, and look at the opposite end of the spectrum. Minus 1 is an error. But straight after minus 1, what do we notice? It's back to being positive, isn't it? Now if you go back to your original diagram, see the way you're down here, and then the minute you cross minus 1, you're all the way up here. So see the way it flips from being really, really, really negative to really, really, really positive. Okay, does anybody know the reason for that? He's down to you? No. Alright. Let me show you. Alright, look at this. I want you all to use the following number for me, okay? I want you to use x equals minus 1.001. I want you to insert that into that equation and tell me what you get as the y value. So replace x with minus 1.001, and I want you to tell me what the y value is. What is the y value?
Minus 1,002.
Huh?
Minus 1,002.
Minus 1,002.
0.2.
Yeah, that's okay, it doesn't matter. Would you agree it's extremely, extremely, extremely negative? Why? You're dividing a really, really, really small negative number into a positive number. Okay? Now, this time I want you to sub in 0.99. That's, minus 0.99. That's the other side of minus 1, isn't it? One of them is a tiny bit to the left of minus 1, and the other one is a tiny bit to the right of minus 1. And what did you get as the y value this time? Anybody? Yep.
98.01.
So, by moving 2 hundredths to the right, you went from a really, really negative y value to a positive y value. That just flipped. Because all of a sudden your denominator was negative, but now your denominator is positive. Does everybody get that? In part 1 your denominator is negative because the x value is more negative than the 1. In the second one your denominator is positive because it's not bigger than the 1. That's what causes it to flip. Now, examining this further, we see that all these are positive, and it goes all the way down to 0, 0. And what happens here is, it never goes negative. Does everybody see those numbers? It doesn't go negative, does it? it stays as fractions, and now it's on its way. It's on its way back up again. And that's reflected here. It goes down, hits 0, and comes back up again. So what are the only y values that are not represented? The y values all have to be bigger than or equal to 0, and the y values all have to be smaller than or less than or equal to -4. So in essence, this is whether you can use your table function or not is the real question here. The y values have to be smaller than or equal to -4, or they have to be bigger than or equal to 0. Anything between -4 and 0 isn't represented. You can't find that anywhere on your table function. Okay? Anywhere on your table function you will not find an answer in between 0 and -4. Just doesn't exist. You can look as hard as you want, ain't going to happen. Okay? Alright, let's move on. That was a tricky question. A lot of table functions to get that answer correct. Alright. This one here. An equation of a quadratic curve. Any ideas how to do this? What's the formula for a quadratic curve? A generic formula. X squared plus c. Great. What can you do next? Any of you know? Sub in the y and x values. So, -1 equals a times -2 squared plus b times -2 plus c. -1 equals 4a minus 2b plus c. You cool with that? What about the next one? The green one. 2 equals a times 1 squared plus b times 1 plus c. You cool with that? Now what now? 2 equals a plus b plus c. Alright, what's the next thing after that then? So in the last one, -16 equals a times 3 squared, yeah, plus b times 3 plus c. And what do we get there? Okay guys, any of you remember how to do these? What are they? Simultaneous equations with how many variables? Would everybody agree the hard part of the question's over now? It's just a matter of polishing that off. You're on your own, isn't it? So you should probably finish that later on and make sure you get the 3 letters that we're looking for. And you just sub the 3 letters back into the original equation. Sub the 3 letters back into the original equation, and then you get the equation you're looking for. Alright? Good. Now, let's go for the next one. Happy enough with that? Alright. So I've done 14 and 15. I'm going to go for 17 now, okay? So, everybody sees that? Okay. What's the maximum? 3a. What's the minimum? Anybody? 5, 0. Is that a repeated root? As in it happens twice. Why does it happen twice? It touches it but doesn't go through it, does it? No. What's the other root? X equals 2. Is everybody happy with the 3 roots? 2, 5 and 5. Okay. Find an expression for the polynomial. This is known as the factor term. If that's a root, what's a factor? What's the other factor? Another x minus 5. Then an x minus 2. Alright, we're going to multiply this out. X squared minus 10x. X squared minus 10x plus 25 by x minus 2. Is that okay with you guys? Now, going to multiply it out, and what do we get? X cubed minus 2x squared minus 10x squared plus 20x plus 20x, yeah, plus 25x. Then after that, minus 50. Now, how can I check if this is correct or not in a minute? So I'm going to get this, oh, I keep doing that, 12x squared plus 45x minus 50. Is that okay with you guys? Now, which point do I know the value of? I know the value of 3a. What has to happen when I sub in 3? Better equal a. Otherwise, it's not the value we're looking for. There's a lazier way of doing this. What's the lazier way of doing this? Table function. Okay. Oh, sorry. And I'm just going to throw it in, and we're going to see if it matches up. I'm hoping it doesn't match up, because it would make it a more difficult question where we could learn more stuff. It better not match up. I don't want it to match up. Alright. I'm hoping it doesn't match up. Okay. We're looking for 3, isn't it? Minus 10 to plus 5. Let's find out what happens at 3. Does that match our description so far? Right, you should be able to tell, you should be able to picture what a graph looks like in your head just using the table function. What's happening at the moment? It's really, really, really negative, which means it's all the way down here. Now what happens as it approaches 2? Is everybody happy with 2, 0? Oh, 3, 4. I wanted 3a. Anybody have an idea how to fix that? Times it by 2. And what does times it by 2 do? It doubles the height, but it doesn't change where it crosses the x-axis. Is that okay? So let's try this out again, except this time that's a 2, you're a 24, you're a 90. Now what's the other one? 100. Alright. Oh, sorry, I forgot to do that down there, but it should be 3h, shouldn't it? There you go, 3a, doubled it. So that's the correct answer then, isn't it? Alright. So,